gentlemen, today we're going to talk about transformation and dilation. This is the transformation unit. Okay? So, we're first going to talk about a transformation is the geometric figure of a geometric figure is a change in the position, shape, or size of the figure. Okay? There are four types of transformation. One is translation, which means to slide. Rotation, which some of y'all know is to turn. Reflection is to flip. And dilation. Okay. So, in a figure, when you're talking about turning or rotating, you're going to have two figures. You're going to have the original figure and then the figure once you rotate it, flip it, and things of that nature. So, your pre-image is the original image, and your image is the image after you do the transformation. Remember, pre counts before you do all the flipping. Now, when we talk about this image, after you flip it or rotate it or reflect it, we use prime notation. So it's going to have a little asterisk beside it. So if the pre-image is A, the new image is A prime. Okay? Now, in geometry, going through a lot of vocabulary, is a transformation in which the pre-image and image, so the before and after image, are congruent. Okay? So, there is one transformation that does not have isometry, and that is dilation. Because the dilation, the image is getting smaller or larger, so they are not. So let's look at these. Which one of these appear to have isometry? This one does. Even though it is rotated, they are still congruent, the same size and shape. This one does not. Number 3 does, and number 4 does. Okay? Now, we're going to talk about translation. This is the first one of the transformations. A translation changes the position but not the shape or size. Slides every point the same distance. So yes, it has isometry because it doesn't change the size. Change size. Okay? Now, we use vector notation. The first value tells you how much you go left or right, because that is the x-axis, left or right. And then the second one tells you how much you're going to go up or down. Okay? So for an example, if you see x if you see -2, 3, that means that you are going to take your x value and go left 2, in the -2 direction, and you're going to take your y value and go up 3. So you're going to go left 2, up 3. So, let's look at this. Each of the following points in A, B, C, D were moved blank to the left and up how many? Well, I'm not going to do every point. I'm just going to take A. Remember, A is your pre-image. A prime is your image. And before I'm going to go from A to A prime. Looks like I'm going to go left. 1, 2, 3, 4, 5. So I went in the negative 5 direction. And then I went up 1, 2. All right? So I went left 5, up 2. Moving left in the negative x direction and moving up in the positive y direction. So if I was to write this in a translation formation, it would be x minus 2, because I went in the negative, I'm sorry, x minus 5, so I went left 5, and y minus 2. I'm sorry, plus 2. My image, my vector image will be negative 5, 2, without the x. Now, let's move these and make a new our image. This is our pre-image. Let's make our image. So this tells me that I am going to go right 2 and down 3. So if I go right 2, I'm going to do it with L. 1, 2, and down 3, 1, 2, 3. That would be L prime. Now I'm going to do the same thing with N and O. If I go right 2, 1, 2, and down 1, 2, 3, I'm going to land right here for N prime. If I start at O and go left 2, sorry, right 2, I'll show you, right 2, and down 1, 2, 3, that would be my O prime. And this would be my new figure. Okay? Now, for the square, it looks like I am going left 1, and I'm not moving anything on the y because as you see, the y doesn't have a plus or minus with it. So that means I'm taking everything and moving it to the left 1. There's J prime, K prime, M prime, L prime. There is my new figure. All right, now translate ABC and 4, negative 3. Now, if you notice, I do not have a picture this time, but I can do it in a table. I'm going to take my x's. This is my x value. This is going to be my y value. Okay? If you notice, it says x4. So that means I'm adding 4 to every x. This one says I'm subtracting 3 to every y. So I'm going to take my first order pair. This is for A. I have negative 2, and I'll put the 4 where the y is. For B, I have negative 1 and a 4. And for C, I have 3 and a 6. So if I add 4 to all my x values, negative 2 plus 4 is 2. Negative 1 plus 4 is 3. 3 plus 4 is 7. Do the same thing with the y. It's going to be y minus 3. So 4 minus 3 is 1. 4 minus 3 is 1. And the 6, and I subtract the 3, or move to the left 3, will give me 3. So my A prime would be at 2, 1. My B prime would be at 3, 1. And my C prime would be at 7. Okay? Now, we're going to describe the transformation from B to B prime. go to the right 7. Add 7. To go from 2 to 4 to 6, I need to add 2. So my vector notation would be x plus 7, y plus 2. Or you can say 7 comma 2. Okay? Now, we've done translation. Now let's do dilation. A dilation is the transformation that enlarges or reduces a figure so that the image is similar to the preimage. For this class, dilation will always be centered around the origin. Now this one is not assumption because it's changing size. Alright? Now, the scale factor. Okay? The scale factor is the length the scale factor is the ratio, of the length of a corresponding size. You always put the image over the pre-image. Okay? If the scale factor is greater than 1, then it's an enlargement. It's getting larger. If it's less, it's a reduction, which is getting smaller. All right, so let's look at the example. All right, let's find the scale factor of this ratio. Well, from here to here is the pre-image. If you look here, that is the post, is the image. So if you need to, you can redraw the triangles. This is x, d, y, with a 12. And then this is x prime, d prime, y prime, with this would be 30. Because you have to add 12 and 18. So you would have 30 over the 12. And if you reduce this, you would get 10 over 4, which is 10 over 4, which is 5 over 2. Okay? So it is getting larger. This is the same thing as saying 2.5. So it's 2.5 length larger than the other. So we're going to decide if this is an enlargement or a reduction. The dotted is the image. The solid is the pre-image. I'm sorry. The solid is the dilation of the dot. So your dotted is your pre, your solid is your image. So you can see if I started with the dotted and went to the solid, this is definitely a reduction. It got smaller. But how much? Let's look. If I take my original image, if I take my image, which is 4, over my pre-image, which is 8. The dotted is the pre. All right? So this is 1/2 smaller than the original image. So if you look at this one, the second one, the solid is the dilation of the dotted. So the dotted is the pre, look at that, that's going to give you 4. So it's 4 times bigger than the dot. And the last one is a reduction, which we're talking about going from the dotted to the solid. And this would be 5 over 15, which is 1/3 the size. All right. To find an image for coordinates for a dilation, all you have to do is really easy. You just multiply by the scale factor. So look at problem number 4. It gives you all these coordinates. And then it says find an image under the dilation centered at the origin with a scale factor of 2. So what you have to do is you are taking the x-coordinate and the y-coordinate and multiplying it by 2. We're doubling where the image is. So -2 times 2 is -4. 0 times 2 is 0. So I'm taking these and timesing it by 2. B, same thing. 0, 2 times 2 is 4. 4, 0, 0, -4. I'm taking each one and timesing it by 2. So that lets me know that this was my original, this is my image, the bigger one is my image, this is after, this one is the before. So this is the before, these are the after. Whoops. Sorry. All right. Now, it is saying graph a pentagon and an image with the dilation of 1.5. So let's go ahead and let's put A as 0, 3, B as 3, 3, C as 3, 0, D as 0, -3, and E as -1, 0. And then if I multiply every one by 1.5, let's see what we get. So this now becomes 0, 4.5, 4.5, 4.5, 4.5, 0, 0, -4.5, and -4.5. Let's start with the float. This is my original. 0, 3, 1, 2, 3. There's A. 3, 0. I'm sorry, 3, 3. 1, 2, 3, 1, 2, 3. That's B. C is at 3, 0. D is at 0, -3. Sorry. 1, 2, 3. And E is at -1, 0. So this is my original pentagon. Now let's go ahead and do the enlargement. So 0, 4.5, 1, 2, 3, 4. Whoops, that's all. A prime. 4.5. 1, 2, 3, 4.5. 1, 2, 3, 4.5. B prime. C is at 4.5, 0. D is at 0, -4.5. And E, I'm sorry, is at -1.5. 1.5, if I need to multiply by the scale factor of 2, it's going to become 0.4. So this new dot should be right here. You are able to do the rest. Okay? Let's do an example over here. This is at 2, 2. Oops. Change my name. 2, 2. The ordered pair, if I do 2/3 of it, it's going to be at 1.3, 1.3. So that's going to be more like right. Oops, let me change color this thing up. It's going to be more of right here. 1.3. Oh, I'm sorry. 1.3, 1.3. So I'm moving over 1.3, 1.3. It's going to be like somewhere right in there. And so it's getting smaller. Okay? All right, that's the end of dilation and translation. Be back in a second.